last unit we were looking at statistics and analyzing data, but we were only looking at data that had one variable. So like, what's your shoe size? You could ask 1,000 people in the school what their shoe size was, and you can make a histogram or box plot of that information and see what the distribution looked like, right? Scatter plots are a little bit different. How many of you have used a scatter plot before? You've seen scatter plots before, right? At some point in school, I'm sure you've seen a scatter plot. Sure, at some point. In scatter plots, the you need two variables. Okay, so you could go around, ask people what's your shoe size and how tall you are, and see if there's a correlation between your height and your shoe size. Do you think there's a correlation between height and shoe size? As somebody gets taller, their shoe size generally gets bigger, right? For the most part, that's what correlation means. But you need bivariate data. Bivariate is bi mean for two variables. Okay, have you heard that word correlation before? Where have you heard that from?
Like there's the same correlation without causation.
Yesterday's extra credit.
Yesterday's extra credit. Yes, if you did the extra credit, you got to jump on this. Talking about correlation, talking about comparing two different things. And a lot of times in the media, especially, or things that we see online, we can see things. People trying to make cases or try to prove something because two things are correlated. But just because two things are correlated doesn't mean that they one cause the other to happen. Okay. Whoops. I'm gonna pin this here. So, vaccines cause autism. You ever heard anybody say that? Yeah. Do you believe that? Most of you are shaking your heads, right? I mean, I think there's a lot of scientific data out there, but just because one thing correlates with the other doesn't mean that one causes the other. I want to show you one of my favorite websites to go to. They update this stuff. These are called spurious correlations. These are things that are correlated and they're spurious, meaning that they're pretty funny. For example, here's a correlation between U.S. spending on science, space, and technology and suicides by hanging, strangulation, and suffocation. But look how strongly correlated they are. They're literally almost identical. But does that mean that how much money we spend on space and technology is causing people to commit suicide? No. That doesn't mean that one caused the other. I can manipulate data a little bit if I wanted to make things look like they're correlated. Okay. What about this one? Number of people who drowned by falling into a pool and films Nicolas Cage appeared in. That's pretty correlated. Doesn't mean that one caused the other. Per capita cheese consumption and the number of people who died by becoming tangled in their bed sheets. You know that's a thing? These are all true data. Like the data is literally real. But it's just showing you that these correlations doesn't necessarily mean that one thing can cause another. Okay. I'll probably show you guys this website again later on this year. I'm gonna have you guys look some stuff up and create your own. You can create your own in there. Anyway, tell me. Let's think back to algebra. X-Y axis. X-axis is horizontal. Y-axis is vertical. Right? Which one is the independent variable? The X or the Y? Yeah, the X is the independent variable. In this particular case, on this graph, it's the taxable income. Okay, so this graph shows you taxable income, so how much money you make that can be taxed, and then how much money you have to pay in taxes. How many of you have done your taxes already if you have a job? Did you taxes? Did you get any money back? How much? Well, not including the stimulus. That's good. I mean, you're probably working like part-time, right? Yeah. Those of you late people coming in, you're going to have to get the code from somebody to get in here. What's the dependent variable in this case? The y-axis. Y always depends on x. That's exactly why our equations in algebra are y equals something, right? Y always depends on whatever x is. Okay, that's the reason why they're that way. And in this case, this is the only thing that makes sense. The amount of taxes that you owe depends on how much money you make, not the other way around. Okay, how much money you make does not depend on how much taxes that you owe. That's not how it works. Okay, but tell me this, and put this in the chat, or unmute yourself, or you guys tell me out loud here. Do you think there's a strong correlation here or a weak correlation? Even without knowing anything, you think it's strong? Maddie says strong. You guys agree? Why do you think it's strong?
Because if you make a lot of money, you get taxed.
Okay. Yes, that's a good answer. Why do you think it's strong just looking at the dots though?
I mean, it goes straight up.
Because it goes straight up. Not just because it goes straight up, because the dots are like literally on a straight line. Okay, they're almost exactly on a straight line. That's what makes it strong. Okay. Answer this question on your screen. I just talked about the correlation. Now I want you guys to interpret the graph. Don't worry about being right or wrong. I'm going to give you about 60 seconds. Put an answer. What is the interpretation of the data? What are you learning from this graph? What is it telling us? Again, don't worry about being right or wrong. You're going to understand it after a couple of examples. Just tell me what you think you're learning from the graph. Make sure you press enter or whatever it is to save your answer so it gets saved in there. Give me about 1 minute. What are you learning from the graph? You got about 50% of people in. Let's get your answer locked in so that I can share a good one. If you're coming in late, you need to get the code from somebody. You're already going to be missing answers. I'm going to share, let's see. It's a pretty good one right here. I say that when you make a lot of money, that your tax is more than someone who does not make a lot of money. That's something that we're learning from this graph. The more money that you make, here we go. This is another good answer. The more money you make, you owe more taxes because it's going up, right? You're owing more money. And generally, that's the case. The more money you make, the more you got to pay in taxes because taxes is going to be some type of percentage. Do you think that rich people who make $1 billion should be taxed higher percentage than you and I? That's a debate for a different day. But yeah, those are different questions that you guys could answer. Okay, but that is definitely something we're learning from the graph. Answer this question now. I'm going to only give you about 15 seconds on this. Is the correlation positive or negative? Is the correlation positive or negative? A or B? Just pick an answer. Positive or negative? You might want to think back to the algebra on this one. Which way is the line going? About 5 more seconds. Looks like you mostly got it right. Some of you didn't answer, but it's 100% now. Good. Yeah, it is positive. Why is it positive? Because that was your first answer, Christian. It's just going up. As X gets bigger, Y gets bigger. As the taxes go up, as the income goes up, the taxes go up. That's why it's positive. So let's look at something that's a little bit different. Take a look at this scatter plot. Don't put this on your screen. Just answer it out loud. Does this graph have a stronger or weaker correlation than the last graph? Why weaker?
It's scattered.
It's more scattered. It is weaker. It's more scattered. Okay. Those of you coming in late, you might as well you're already going to be missing stuff. You're not going to be able to get 100% credit. It's weaker. The data points are more spread out. Can you still see a relationship with it though? Do you think it's still linear? Watch this. You can still make kind of like a linear line. It's definitely linear, but it's a little bit weaker now for sure. What about this question? Is it positive or negative this time? It's negative. Why? It's going down. As X gets bigger, Y is getting smaller now. So this is a negative relationship. You guys are right. Good. So answer this question. Now interpret the graph. Tell me your interpretation of this graph. I'll blow it up big for the screen. Interpret this. What's happening here? It shows the driver's age on the x-axis as the independent variable. It shows the max distance to read the sign on the y-axis. What's our interpretation of this information? Or in general, what's happening? As you get older, your eyesight gets worse. Is that true? I mean, is that true in general? I can't see crap out of my right eye. If it's dark at night, I have a hard time seeing when I'm driving. I'm getting old. The more older you get, the closer you have to be to read the street signs due to your eyesight. Yeah, old people can't read traffic signs in a certain distance. Yeah, as we get older, our eyesight gets poorer, and that's just the way it is. And this particular graph is kind of proving that. It's not always the case. Look, there's a 75-year-old up here that's seeing better than all these young people right here. So it's not always the case, but generally it looks like, and a couple of you guys use that word generally, this is what happens, right? Okay. Make sure you lock your answer in. What about this one? How would you describe the correlation between number of siblings and number of pets? This is a graph that has shows the correlation between number of siblings and number of pets. Is there a very weak positive correlation? Is there a very weak negative correlation? Or is there just no correlation at all? What do you think? Maybe like 10 seconds on this one. There's a breakdown of the answers. No correlation at all. One, the majority, and no correlation at all is the correct answer. It's okay to have no correlation. In this particular case, I mean, does the number of siblings depend, or the number of pets depend on how many siblings you have? No, not really. Not unless your parents are like, well, every kid gets one pet. How many pets do y'all have? Two? What, dogs? Cats? Dog? I just have one dog. Any of y'all have any other cool pets? You have a pig? Like a pet pig? 3 pigs? What are their names?
One is Layla.
Layla? And what else?
Oh, I don't know the rest of them.
They don't have names?
They do, but Chippendale.
Chippendale?
Chippendale. Yeah.
Chip and Dale?
Yeah.
Oh, that's funny. And what do you do with the pigs? You play with them?
No, they're not mean. They get scared easily.
And what do? They just hang out in the house?
Oh, not pets. They're like outside.
They're outside?
They're like, yeah.
Do you have other farm animals?
Chicken.
Chickens? You get eggs from them? I love fresh eggs. How many of you drive? Okay. What happens when you increase your speed in terms of your miles per gallon? You bought a car, right? It tells you the miles per gallon if you're driving in the city. It tells you your miles per gallon if you're driving on the highway. Why does that make a difference?
Well, you get the gas pedal, more gas goes into the engine.
Yeah, so if you're having to stop and go in the city all the time, you're not going to get as good of gas mileage if you're just cruising down I-35 all the way to Canada or all the way to Laredo, right? It's the one highway that connects 3 different countries right there. Do you know that? 35 connects Mexico through America all the way to Canada. It's the only highway in the United States that splits twice. The only interstate that splits twice. Do you know where it splits? Who knows where? You should know where it splits in Texas.
Austin?
No. Where does I-35 split in Texas? What happens when you keep going north in Austin? What's the next big city you hit? You guys know I-35 splits into Fort Worth and Dallas? And then on the other side of Fort Worth to Dallas, it comes back together. And it goes all the way north through Oklahoma, Kansas, all that. Gets to Minnesota, it splits again in St. Paul and Minneapolis. And then on the other side, it comes back together and goes into Canada. Learn something new every day, right? Tell me if you think there's a strong or weak correlation here. Strong. Why? You're right.
It's a straight line.
It's not a straight line. It's not linear anymore, but it's still following a pattern, right? It's still following that pattern. It's definitely not linear anymore because it's making like it's going up and then it's coming back down. But it's still a strong relationship because they're bunched together. It's still following a pattern. What are we learning from this? Well, the faster you go initially, the better gas mileage you get. Until what? Well, until about 55 miles, 60 miles per hour, then the gas mileage starts to go down again, right? And so, have you ever heard your parents tell you, like, if you speed, you use more gas? I mean, that's true. At a certain point, you're going to use more gas if you're speeding than if you don't speed. So don't speed because that's against the law anyway, right? In this unit, we're going to be describing correlations a lot with scatter plots, all looking at a lot of different scatter plots. Okay, you got to talk about three things. One, tell me what the strength of the scatter plot is. Is it strong or weak? But don't just say strong or weak. Tell me it's somewhat strong, very strong, fairly weak, somewhat weak. Okay, use an adjective. All right, there's some graphs that are stronger than others, so use an adjective to describe that. The second thing is tell me if it's what direction it's going. There's only two options. It's either positive or it's negative. Okay, those are pretty easy to figure out. Last, tell me what the relationship is. Is it linear or is it nonlinear? Okay, there'll be other ones that we talk about that are not linear, but for the most part, either tell me it's linear or not linear. Okay, when we learn about the other ones, you can tell me about the other ones. So here's some practice. Let's do a matching game. Let's see. I'll give you about 2 minutes to match up the vocabulary. On your screen, you might need to pull this little button up here because it has the directions, match the correlation descriptions with the correct scatter plot. So press this little button right here so you can see all of them and match up the description with the correct scatter plot. Let's see how you do. Last period, eventually everybody got the 100% matching. So if you log in again, you can log in with the same code. If you log in with your Z64HG.
4HG?
Yeah, Z64HG.
It should keep the same.
If you're logged in with your same Google.
Okay.
Yeah. If not, it'll start you where we're at, and then I'll be able to see both parts because it saves what you did before.
Okay.
Matching game. If you miss one, it should let you uncheck it and pick another one, right? Yeah. Is there any one of these you're not sure about? No correlation? Definitely that one. Yeah. So you see how these can be described here. Anybody need any more time? Let me know. We're almost done. All right. So I'm going to leave you guys with an exit ticket here. But before I do that, we're going to do one practice together. And I'm going to show you exactly what I want on this exit ticket on the question that gets graded. 2 parts. Take a look at this scatter plot. Shows the relationship between a husband's age and a wife's age. What's the correlation? We need to talk about 3 things, Jimena. The strength, which direction it's going, and what form it's in. Is it either linear or nonlinear? So how strong is it?
Somewhat strong.
Somewhat strong. Okay. Which direction is it going? Positive or negative? It's positive for sure. And is it linear or nonlinear? It's pretty linear. I mean, it's pretty straight line, even though it's not super, super strong. It's pretty strong. And in statistics, this is actually probably more than somewhat strong. It's probably fairly strong. And that's what I wrote here. It's a fairly strong, positive, linear correlation between husbands and wives' ages. Okay. So when I ask you to describe the correlation, this is what I want you to say, all three things. But you can do it in one sentence. That's it. One short sentence. Got it? Second part. Interpret the graph. What is this telling us? What's the graph telling us? What are we actually learning from this graph? You're not writing the answer in here yet. You're just going to tell me what you think. Anybody at home? Gracie? Jayla? Taylor? Trey? What are we interpreting from the graph? What's a generalization we can make?
Husbands marry young.
Are they really?
Or like men marry young. Yeah, the men are older than the wives.
Not by a lot, right? I think it's
Kind of.
by a lot.
No, not by like a lot. But
No, yeah, not by a lot. But I wouldn't say husbands marry young. I would say maybe they marry people that are a few years younger than them. But if you look at all the data points, for the most part, what do men and women tend to do? They tend to marry somebody that's about the same age, right? Or within a couple years of each other. And that's an interpretation. That's a generalization that we can make. Hey, we tend to marry people around the same age within a couple years. How many of you have parents that have a large age difference? Somebody earlier told me 10 years they had their parents. 11 years? Dang. How old were they when they met?
Mom was 16.
Your mom was 16, he was 27?
Again.
Oh, that's a...
That's what it says.
No comment. All right. So you see the difference between correlation and then interpreting what we're learning. Okay. That's what you guys are going to do here in just a second. You ready for your exit ticket? All right. Before I give you your exit ticket, how many of you want me to put that? Anybody at home want that extra credit up? I will reactivate it because I'm a nice guy. But I'm going to close it at midnight tonight. Okay. You guys are going to get that stuff in. All right, here's your exit ticket. And please see that there's two parts to this. Okay, this is the graded question, so make sure you're answering both parts. First, you're going to describe the correlation of this graph. So tell me how strong it is. Is it linear or is it positive or negative? And is it linear or nonlinear? Then the second part of the question is to interpret the data. So tell me what you're learning from the graph. Don't log off yet so I can give you guys credit for coming in today.